Hello, my name is Edwin Liu, and my presentation is titled Three-Layer Multi-Criteria Approach to Assessing Relative Risk of Contracting COVID-19 for Various Activities. As you all may know, COVID-19 has greatly affected the daily lives of billions of people, causing many to lose their jobs and forcing people to transition to at-home jobs or risk their physical well-being by leaving their homes. Despite the rapidly increasing vaccination rate of United States citizens, there is still cause for concern due to variations of COVID-19, such as the Delta variant, along with potential wear-out of the original vaccine. The chart on the right shows weekly COVID cases in the United States by variant. The Delta variant, or the B.1.617.2 variant, can be seen as the orange bar that slowly increases in size as the weeks go by. As such, by understanding the effects of various safety methods on infection rate, we can better approach future scenarios where safety measures may be necessary. A factor to consider is that different locations will be affected differently, mostly due to infection and vaccination rates. In the US, for example, there is a notable infection variations in different localities, as can be seen in the infection maps of Virginia and North Dakota. Research objectives. So, the main research objective was to create a decision model using an analytical hierarchy process that, given a user's routine activities, how often they leave their home, and other information, could estimate the likelihood of them contracting COVID-19. We can consider factors such as workplace sanitation, travel frequency, and social distancing, just to name a few. So what exactly is an analytical hierarchy process? An analytical hierarchy process, or AHP for short, was first introduced by Thomas Sadie in 1977 and is used to analyze complex decision-making problems. AHP has been applied to various fields such as business, education, and government, and aids decision makers in finding decisions that best match their goals. AHP works by first dissecting a decision problem into a number of criteria and using those criteria to create a hierarchy. This action is then followed by comparing the aforementioned criteria pairwise and constructing a comparison matrix. We will begin by discussing the second step, creating a comparison matrix. On the screen, we can see an example 3x3 comparison matrix with several factors. In this case, we weigh hygiene as 5 compared to exercise, meaning that hygiene has a stronger importance to safety than exercise, as can be seen in the chart below. A 1 would signify equal importance, so for example, comparing any two of the same elements will give us a 1, as can be seen down the diagonal, while a 9 will signify extreme importance. The even numbers signify an importance between two odd numbers, so for example, a 4 would signify between a moderate, which is a 3, and strong, which is a 5, importance. For the other entries, we take the reciprocal of the entry mirrored across the diagonal. For instance, since we weighed hygiene as a 5 compared to exercise, we weigh exercise as 1/5 compared to hygiene. Next, once a comparison matrix is created, we can then calculate the principal eigenvalue, which is the eigenvalue of the matrix with the largest absolute value, along with its corresponding eigenvector. After normalizing this eigenvector, we obtain the priority vector of the matrix, which signifies the relative importance of each factor. In the example shown, we have a priority vector with 0.075 0.333, and 0.592 as its entries. This tells us that according to this matrix, since work has the highest entry value in the priority vector, it's the most important factor, followed by hygiene and then exercise, respectively. Finally, the consistency index, or CI for short, is calculated by taking the principal eigenvalue, subtracting it by the order of the matrix n, and then dividing it by n minus 1. In this case, we have n equals 3 and can calculate the corresponding value. Next, we can calculate the consistency ratio, or CR for short, by dividing the consistency index by the random consistency index, which is a value determined by n according to the chart below. The consistency ratio allows us to assess the consistency of the matrix. So a consistency ratio below 0.1 or 10% indicates a consistent matrix, while a value above 10% indicates that we may need to revise the comparisons. In the example shown, the consistency ratio is 1.36%, indicating that the matrix is consistent. Now let us take a look at the first step mentioned earlier, creating a hierarchical diagram. At the top, we have our goal, COVID-19 infection prevention. This is considered the 0th level. On the first level, we see our main criteria, which in this case are hygiene, exercise, shopping, social, and work. Next, we have our sub-criteria, which are simply subcategories of each of the main criteria. So both of these, both the main criteria and sub-criteria will be discussed in more detail later on. So lastly, on the third level, we have our alternatives. Note the notation C11, C12, etc. for the sub and main criteria, as this will be used in some of the later slides. So to begin, we will talk about the several alternatives used first. Each alternative is characterized by the activities a person does or does not do. For example, a sedentary lifestyle would generally entail working from home and shopping online, while a very active lifestyle would involve going to the office or frequently attending social gatherings. A partial sedentary lifestyle would involve going outside to shop every once in a while and sometimes working in person, while an active lifestyle would involve frequently leaving the house for work, shopping, or social gatherings, albeit less so than a very active lifestyle. These lifestyles will be denoted in future slides by S, P, A, and V for sedentary, partial sedentary, active, and very active, respectively. So now we can see on the screen our 5 major criteria, which are the same as the ones shown in the hierarchical diagram from before. Our first major category is hygiene, which includes sub-criteria such as social distancing, proper sanitation, etc. Exercise refers to going to the gym, taking walks outside, or participating in team sports. Shopping and work are relatively self-explanatory. Social will refer to social gatherings and traveling. So to begin, I'll be explaining in detail the calculations used for the hygiene criteria, and for the rest of the criteria, only be showing the results. So for hygiene, we have 4 separate sub-criteria, which are wearing masks, social distancing, washing hands, and workplace sanitation. Workplace sanitation refers to either workplace or school sanitation depending on whichever environment suits it. The other 3 factors are relatively self-explanatory. Note that the sedentary lifestyle will always be the safest, as not wearing a mask or social distancing is not an issue if an individual does not leave their home, although washing your hands is still a good idea regardless. This is generally true across all criteria, as staying home as much as possible is the most surefire way to stay safe. Moving on to the next slide, we can calculate the priority vector and consistency ratio for all four matrices. Note importantly that the consistency ratio is under 10% for each matrix, implying that each matrix is consistent. Lastly, we can append each priority vector together and compare how important each factor is for each lifestyle. By doing this, we can decide which practices are most important for public safety and use this to calculate individual risk. Moving on, we will now talk about the subcriteria for the major criteria exercise. For exercise, we have three main subcategories: team sports, gym usage, and outdoor activities. The team sports criteria comprises of sports such as soccer, football, or basketball, and generally involves a significant amount of close contact with teammates or opponents. Gym usage indicates the relative safety of an individual attending the gym, while outdoor activities is about the safety of outdoor activities such as hiking or biking. Next, let us talk about the subcriteria for shopping. We have three subcriteria for shopping, which are shopping hour, cleaning bags and packages out, and outdoor shopping frequency. Shopping hour is important since shopping at a convenience store at 3 a.m. is quite different from shopping at noon on a busy Saturday. This influences the number of people an individual may be in contact with when they shop, and as a result, the potential risks they may face. Cleaning bags and packages out or letting them sit for several days is also an important factor to consider. Lastly, due to the invention that is online shopping, it's important to consider whether or not an individual even leaves the house to buy food or other necessities. For the social category, we have three subcriteria: social gatherings, eating out, and traveling. These three subcriteria are relatively self-explanatory. Attending gatherings with a large number of people, or generally going to any public area, will certainly have an effect on safety, and this is displayed in the charts. Social gatherings such as birthday parties or weddings have a relatively high value for the sedentary lifestyle, indicating the importance to safety of not attending such events. So for work, we don't have any subcriteria. The main reason is because a person's job will generally determine their work environment. If they work in a restaurant, they must work indoors. Similarly, if they work in computer science, they most likely have the option of working at home. Thus, since we already have workplace sanitation covered in the hygiene section, our main criteria, work, encompasses generally the risk an individual faces on a daily basis in regards to work. Additionally, we can pairwise compare the subcriteria for each criteria. This allows us to assign global weights to each criteria, which are each of the priority vectors we see here, which can then be used to calculate the overall priority vector. By appending each priority vector, we can obtain our final matrix. This matrix allows us to see how each activity affects the risk of contracting COVID-19 based on individual lifestyle. The significance of this is that it allows us to provide specific guidance to people to help protect them against COVID-19. Additionally, by combining this matrix with the subcriteria global weights from before, we can calculate the relative safety of each lifestyle. So in conclusion, we can use these values to calculate the risk an individual faces on a daily basis. In addition to this, we can simulate what-if scenarios to give individuals a better understanding of their potential exposure if they change certain aspects of their daily routine. So that concludes my research. For future research, we can evaluate weights based on local infection data and/or for different population groups. Additionally, surveys can be conducted to obtain more accurate pairwise comparisons, or fuzzy AHP can be utilized to capture ambiguity in pairwise comparisons. This is a list of research references. Special thanks to my advisor, Professor Yu of the Department of Mathematics at the College of William & Mary. And thank you for listening to my presentation. If you have any further questions or comments, you can contact me at edwinliu99@gmail.com.